Looking at trigonometric identities. So, some more things that we need to talk about. A function is periodic if there exists a positive number, p, such that f of t plus p equals f of t. So basically, periodic functions, our trig functions are periodic functions. Sine and cosine, if you add 2 pi for sine and cosine, then you get back the same value. And we'll talk about this more when we look at actual pictures of the graph. So, since the period of sine and cosine is 2 pi, every 2 pi we are repeating. And therefore we get the same thing. And if you think about that unit circle wise, okay, you get around 2 pi, you're getting the same values as you go around beyond that. Tangent and cotangent repeat every pi. And then secant and cosecant would be the same as cosine and sine. They would repeat every 2 pi also. So these are some periodic properties here that you'll need to be able to use. So example 1 asks us to find the value of each trig function here. So knowing that 5 pi over 4 is pi over 4 plus pi, then we can say that the cotangent of 5 pi over 4 is the same as the cotangent of pi over 4 plus pi. And the cotangent of pi over 4 is 1. So just another thing in our repertoire to help us find these values. For the cosine of negative 9 pi over 4, well, is there something that we can add to 2 pi to get 9 pi over 4? Because cosine repeats every 2 pi. 9 pi over 4 is the same as 2 pi plus pi over 4. Think about it. 2 pi is 8 pi over 4, and 8 pi over 4 plus 1 pi over 4 is 9 pi over 4. So the cosine of negative 9 pi over 4, first off, going back to our even-odd properties, the cosine of a negative is the same as the positive of the angle. So that is the same as the cosine of 2 pi plus the pi over 4, or the cosine of just pi over 4. And the cosine of pi over 4 is root 2 over 2. We say that because these are periodic, they are repetitive. So this is the same deal. Sine and cosine are 2 pi. Tangent is pi. And the ends in there are just saying it can be any multiple. So we could have, we could plug in here a 2 pi or a 4 pi making n 2. We could make n 3 and multiply by 6 pi. Okay, we could make n negative 1 and multiply by negative 1 or negative 2 pi, adding to whatever angle we're talking about. And with tangent, it's just pi. So if n were 2, then it would be 2 pi. If n were 3, it'd be 3 pi, so forth. Reciprocal identities. These are very, very useful. We've kind of hinted on them already. Sine of an angle is the y value, remember? And cosecant is 1 over y. So it would make sense that the sine is equal to 1 over the cosecant. Cosine is equal to 1 over secant. Remember, they both deal with x. Tangent is equal to 1 over cotangent. Remember, tangent was y over x. Cotangent was x over y. So it makes sense that that works. Then cosecant, this is just going back and forth. So cosecant is 1 over sine. Secant is 1 over cosine. And cotangent would be 1 over tangent. You can go either way with those. And then there's the quotient identities. Tangent was y over x. So since sine is y and cosine is x, it would make sense that tangent would be equal to sine over cosine. And then with cotangent, since cotangent was x over y, it would make sense that cotangent is equal to cosine over sine. So these reciprocal identities and quotient identities are going to be very, very useful for us as we go forward. Example 2 says, given that sine of t, whatever angle, we don't know what it is, but given the sine of the angle is 2/3 and the cosine of an angle is square root of 5 over 3, find the value of each of the 4 remaining trig functions. Okay, so we've got sine and cosine. Could we find tangent? Well, tangent is sine over cosine. So that means that since sine is 2/3 and cosine is root 5 over 3, then we can just plug in, flip and multiply. The 3's go away. We've got 2 over root 5, which will reduce to 2 root 5 over 5. So there's tangent. Okay, then we can go for, the opposite of sine is cosecant. Cosecant is 1 over sine. So we can just say 1 over 2/3, which is 3/2. Opposite of cosine is secant. And I know I say opposite, it's not really opposite. That's just the easiest way to think about it, I think. So secant is 1 over cosine. And since cosine was root 5 over 3, then secant is 3 over root 5 or 3 root 5 over 5. So there's 4, last one, cotangent. Cotangent is, you could either use 1 over tangent or you could use cosine over sine. Either one will work. So that's root 5 over 3 over 2/3. Flip and multiply, root 5 over 2. So if you're given 2 trig functions, you can find the other 4. For example 3, it says, use the properties of the trig functions to simplify. Okay, so we want to take this that says tangent of t plus pi times cotangent or cosine of t plus 2 pi and reduce it. We can do that because we know that tangent is periodic and repeats every pi. So tangent of t plus pi is just tangent of t. And we know cosine repeats every 2 pi. So cosine of t plus 2 pi is just cosine of t. We're wanting to reduce this so it's in terms of sine and cosine. So we've got a tangent here. What we can do then is use the fact that tangent is sine over cosine. And we have this. So this gives us sine t times cosine of t if we multiply over cosine of t. Realize that your cosines will cancel out. And simplified, we get sine of t. So that means that the tangent of t plus pi times the cosine of t plus 2 pi is equal to the sine of t. Getting tongue-tied. Okay, let's look at a couple more. So here we have 3 sine of t plus sine of 2 pi minus t. Well, sine is periodic, so sine of 2 pi minus t would be the same as the sine of negative t. And we're told by even and odd properties that the sine of negative t is the same as minus negative the sine t. So we have 3 sine of t minus sine of t. Guess what? That's 2 sine of t. And then the last one like this, sine of negative t, that's negative sine of t, times secant, we'll leave that for now, and then tangent of negative t is negative tangent of t. So let's simplify this a little bit. I'm just going to take that minus a negative and change it to a positive here. Now, let's talk about secant and tangent. Secant is the same as 1 over cosine. And tangent is the same as sine over cosine. So what we've got here is negative sine over cosine plus sine over cosine. They cancel out. 0. So sine of negative t times the secant of t minus the tangent of negative t is 0. The Pythagorean identities. These come from the Pythagorean theorem, okay? I may ask you to prove them at some point. Maybe I'll ask you to prove them for extra credit or something. But the Pythagorean identities say this: sine squared plus cosine squared equals 1. Very, very, very important to us. This also implies that 1 minus, or let's see, that sine squared would be equal to 1 minus the cosine squared, by the way. Or that cosine squared is equal to 1 minus sine squared. Then we know that 1 plus tangent squared equals secant squared. And again, you could move things around by adding or subtracting. And 1 plus cotangent squared is equal to cosecant squared. Example 4 says, given that sine of t is 1/2, and that t is between 0 and pi over 2, find the value of cosine using a trigonometric identity. Now, first of all, let's talk about this 0 to pi over 2. Where is 0 to pi over 2? That's in the first quadrant, okay? So this is important information. Since t is in the first quadrant, since our angle is in the first quadrant, that means that our answer is going to be positive. If it wasn't in, if it was in the second quadrant, then our answer could be negative, just depending, or in the third or the fourth. So you have to think about, first of all, this is important, what it says here, for knowing whether your answer is going to be positive or negative. So again, since it's in the first quadrant where x is positive and y is positive, we're all good there. So we're going to use a Pythagorean identity, since we've got sine up here. So then obviously we're going to use sine squared plus cosine squared equals 1. So we know that sine is 1/2. So that's 1/2 squared plus cosine squared equals 1. It'll give us 1/4. Subtract 1/4 from both sides. 4/4 minus 1/4 is 3/4. So take the square root, and we know it's positive. So it's just positive the square root of 3/4, which will be the square root of 3 over 2. And that concludes this section.